We're honored to host this energy category sponsored by Honda Innovations, which is dedicated to exploring emerging technologies and fostering innovation to shape the future of mobility and beyond. And GTT, a leading engineering company in containment systems for the energy sector. Now, I'm very happy to introduce our first jury member, Orion Legris, an aerospace physics engineer by training, who is deeply passionate about deep tech and climate tech startups. She believes in tackling the environmental impacts of human activities and is proud to contribute, albeit humbly, alongside amazing founders. Orion aims to accelerate impact-driven startups with Honda through funding support initially. She invites early-stage founders and startups to reach out and join her in sustainably transforming the mobility industry. Orion, s'il vous plaît.
Hi everyone, really happy to be here, excited to be part of the jury for the Energy Track this year. So before kicking it off and leaving the stage to the amazing finalists we have here, I just wanted to say a few words about Honda Accelerator Venture. So first of all, a little disclaimer, we are not an accelerator per se, we are actually the strategic partnership and venture arm of Honda. And our mandate and mission is to seek carbon neutrality and safety through innovation. So to do so, we globally engage with early-stage startup in partnership and direct investment, usually seed to Series A company, deep tech, climate tech, obviously related to mobility, but we also like to have a systemic approach, considering, for example, where do you source your material, how do you manufacture, how do you power sustainably your assets, and how do you deal with the end of life. So to back up the founders, we have deployed a fund of $800 million out of the balance sheet over 10 years, and we roughly started a year ago. A little bit about the team, because I do believe it's important to know who you would be engaging with, discussing with us. So we are located in the Silicon Valley, in Europe, Berlin, myself and my amazing colleague, Julien Fredoni, and in Tokyo, Japan. So about us, most of us are engineering backgrounds, are a very extended experience in corporate venturing, and we are passionate and really, really motivated by expanding our scientific knowledge, exploring, tackling complex topics together, building some synergies, and also very important, having fun, which is what I wish you today for this session. Thank you very much.
Thank you. I see you got the energy vibe in you, but you also have some fans in the audience, I think. So.
Yeah?
Do you have fans? Yes! That's a fan, okay?
Thank
now,
you.
let's see if you can keep up with the rest of the 3 jury members and the 7 startups, right? Now, we go to Hélène Lançon. She's leading GTT Strategic Ventures, the corporate VC arm of the GTT Group. The fund is primarily interested in future mobility, energy transition, and smart maritime technologies. Hélène brings 15 years plus of experience in industrial innovation and M&A and entrepreneurial teams who share GTT Strategic Ventures goals of developing technologies for a sustainable future. Hélène, s'il vous plaît.
Thank you very much. It's great to be here, and again, because we were sponsor of this great track last year, and we do this because we still believe that technology is a key enabler of the energy transition. And we believe that because 60 years ago, GTT also was a kind of energy technology company, designing a very efficient energy storage technology, and then over the years, expanding to other applications, using our technologies to use LNG as a transition fuel for shipping, but also entering into hydrogen production, hydrogen transport, and CO2 capture. So we're extremely excited to co-host this energy track again, to open our minds on the amazing technologies that are going to be presented today and that represent the future of energy. Thank you very much.
Our third jury member is John Bell. He's CEO of High Tech Excel. He brings a lot of years of corporate experience with Johnson & Johnson, JLabs, or former executive at Philips. And one thing that you need to remember about John is that he wants to be the #1 deep tech venture builder in the world. John, join us. Thank you. And last but not least, Nicolas Auzet. He's the CEO and co-founder of Switch Energy. He has spent the past 20 years developing and financing global tech startups, which led him to one firm conclusion: science and technology will provide an array of powerful solutions to the biggest challenges of society. At Switch Energy, he and his team have leveraged osmotic power to broaden the frontiers of renewable energy and enable a net zero 2050 scenario. But more importantly than this, do you know who Nicolas is? Yes. You know, because we were here last year. So Switch Energy is the grand winner of Hello Tomorrow 2023. So let's give him the biggest round of applause of today. Nicolas. I have a feeling you feel much more relaxed this year than last year. Okay, so let's go to our first startup. All the way from New Zealand, we have with us Christina Houlihan. She's the CEO of Bespicle, that solve manufacturing challenges to help clean hydrogen and achieve scale and affordability.
How do we achieve affordable, clean hydrogen? We can produce clean hydrogen through a process called electrolysis, which is when you use electricity to split the water into hydrogen and oxygen. But if you look at the analyst reports, to split water into hydrogen and oxygen. Now, we know that renewable energy is a core part of the price of hydrogen, but if you look at some analyst reports, they wave a magic wand and say technical innovation will happen. That is where Bespicle comes in. We are that technical innovation. We manufacture catalyst-coated membranes that go into electrolyzers to produce clean hydrogen. The problem is that until very recently, catalyst-coated membranes have not been needed at any type of scale. We were able to manufacture them in thousands per month. We need millions per month as soon as possible. Those challenges come from the fact that we do not have the ability to mine enough iridium metals to meet the growth in demand. We also need to improve the efficiency of the catalyst-coated membranes, because the better they perform, the better we use the electricity, and the cheaper they become. And the last part is we need to manufacture at scale. That is where Bespicle's technological innovation comes from. We have used an approach from the semiconductor industry that enables us to apply platinum and iridium nanoparticles of catalyst onto the surface of that membrane in one single step. We've also developed it into a reel-to-reel manufacturing process, which enables us to produce an electrode in less than 45 seconds. Compared that to the established process, where you need to make the ink, you need to coat the ink, you then need to dry it, you then need to transfer it, you then need to press it, it is a significant improvement above the status quo. But what really excites me is how we produce that clean hydrogen, that more cheaper clean hydrogen. What you can see today is that the cost of a catalyst-coated membrane is very expensive, and the target set by the US to unlock that $1 per kg hydrogen price is quite a big leap. But today, Bespicle's technology is able to come incredibly close to that 2030 target. And we know that when we achieve scale and we improve our performance even further, we can beat that 2030 target. So my name is Christina Houlihan. I'm the co-founder and CEO of Bespickle, and my co-founder Jerome Levenure is our technical expert, an expert in ion beam. I believe that affordable hydrogen comes when we have a Bespickle catalyst-coated membrane in every electrolyzer.
Thank you. Let's go to the jury. I see already, yeah?
Yeah, thank you for your pitch. First question on my side. So could you tell us a bit more about the ion beam technology that you develop, given that it's an expensive legacy from the semiconductor industry usually?
Yeah, absolutely. So ion beam technologies in the semiconductor industry are batch processes. They operate in a defined small vacuum, and you have to put the semiconductor bases in on a one-by-one basis. The real innovation for us has been to change how that system works and turn it into a reel-to-reel manufacturing process. So it's no longer batch, and we can do it on a very large scale, up to 16,000 meters squared for our current system and a gigawatt for our next one.
Thanks.
Christina, can I go to the customer side? So you come up with a new solution. How do your customers respond so far?
Yeah, absolutely. We have NDAs in place with 3 electrolyzer manufacturers. We have research collaborations forming with 2 of those. And they're very excited to see how dry electrode manufacturing will develop and how our technology grows into the market.
Good. Hélène?
Yeah, and Christina, what's your business model?
We're a supplier. So we manufacture the catalyst-coated membranes, and we sell them on to those electrolyzer manufacturers.
Nicolas? You have a mic?
Yeah, tell us maybe about your team. How many of you? Are you 4 people now? What are your background?
We're 6 now. So we have a team of engineers who are working on our scale-up to achieve the gigawatt manufacturing, and we have a team of electrochemists as well to develop the next stage of our product.
And where the technology comes from?
Yes, so we come from a research institution in New Zealand called GNS Science. It's a government-backed lab that specialises in ion beam science for the last 40 years.
And do you own the technology, the patent?
We will in our next raise. That IP will transfer from our research institution to us.
Oriane? Oh, sorry.
And what about competition?
Yeah, we're not alone. So in the last year, several startups have emerged in the ultra-low iridium and platinum space. They specialize either in the platinum, ultra-low platinum space and targeting fuel cells, or they are in the iridium side, but on a different part of an electrolyzer system, which means they don't tend to be able to do the single catalyst-coated membrane both sides at the same time. That is our unique difference.
I see in this world also moving towards membraneless electrolyzers. If that happens, are you out of business?
Absolutely not. So membrane electrolyzers tend to need a down-step processing stage to separate the hydrogen and the oxygen apart. That hydrogen generally is less pure than what you get from an electrolyzer system, which means it's less suitable for the fuel cell applications and the transport applications.
Thank you.
Thank you. Cheers.
Let's move now to Germany with Icodos and David Streetmatter, who's CEO and co-founder of a company that defossilizes chemistry and shipping via lowest cost e-methanol production. David?
Hello Paris, I'm David Streetmatter, co-founder and CEO of Icodos. That's not the presentation I shared with you.
Let's just go with it.
Can we maybe restart the timer then? I mean, I think that's not really fair otherwise.
Yeah, we will.
Then
restart.
let me quickly...
Is it completely wrong?
That slide is not right. There might be a missing slide. Yeah, there's definitely a very important slide missing.
Can you talk about it? Do we need to see it?
Yeah, I think you need to see it.
Okay, so we can't see it. So
It's not part of the presentation.
I know, but let's find a way now.
I mean, if it's okay, then I just do my presentation, yeah?
I'm sure. Yeah. Let's go start the timer now. Is that okay?
That's fine, yeah.
Lovely.
Okay.
You get 30 seconds more. Is that okay?
No, it's fine. It's totally fine. Just, all right. Then, let's go. Hello, Paris. I'm David Stripmatter, co-founder and CEO of Icodos. Icodos will defossilize chemistry and shipping via patented breakthrough e-methanol production technology. Shipping and chemistry have a massive problem. They emit about 10% of global greenhouse gas emissions. And without sustainable fuels for shipping and without sustainable platform chemicals, this will not change. And these industries have realized this. And consensus has emerged that sustainably produced methanol is the solution. However, today's production technologies for state-of-the-art sustainable methanol production are and will never be able to produce sustainable methanol cost-effectively and in sufficient availability, because they are inefficient, inflexible, and highly capex intensive. The result is sustainable methanol is at least 3 times as costly as conventional methanol and fuels, and there's a massive supply and demand gap. The solution, Icodos patented breakthrough e-methanol production technology. Our technology enables our customers to produce sustainable methanol at the cost of conventional methanol and fuels and ensure availability, because it provides the highest degree of flexibility when it comes to utilize the scarce feedstock sources. Based on a decade of R&D experience of our CTO, Icodos developed a fundamentally different, superior technology for e-methanol production. The technology was validated more than 2.5 years ago with Lab Plant, which you can see behind me, and with a pilot plant that was last year commissioned, Icodos is ready for scale-up. And the mission we're working on is clearly supported by a clear growth path with multiple LOIs signed along the whole value chain. First paying partnerships with industrial clients, multiple opportunities in development, and more than 14 million euro in public financing acquired by our technology. And the opportunity is massive. I would love to show you a slide on that, but what you can see on that slide, it's a 600 billion euro total addressable market and more than 1 gigaton of GHG abatement potential per year by 2050. And the competition is that we differentiate ourselves clearly in 2 dimensions. First, we provide the highest degree of flexibility to our customers to produce sustainable methanol, and we have a patented technology that enables a clear cost advantage for the production of sustainable methanol for them. A clear proof point is we are the first and only company in the market to have acquired Horizon Europe money, which requires that the technology goes far beyond the state of the art. And the team is very right to push this forward. I'm a former management consultant, used to work for McKinsey, where I mainly advised climate technology companies and helped them to grow. Francisco Vidal Vazquez, our CTO, has more than 10 years of experience in the exact right field, and Jens has more than 2 decades of experience in the chemical industry, where he built large-scale chemical plants from concept to fully optimized operation. Thank you.
Thank you. Could you tell us a bit more about the technology and how you can actually reach such a low cost, please?
Yeah, I answer very briefly. 2 innovations, a process that is patented, a new approach to produce e-methanol, and the second innovation is a fully dynamic and fully automated process and operation of the whole plant. I can go deeper, but let me know.
Is this your technology? Is it patented?
Yeah, my co-founder has a PhD in that field, and based on his postdoc experience, he developed that with the KIT. Icodos is the exclusive licensee with a buyout option of the patent, which is owned by the KIT right now. So a research institute.
Okay. Ellen, John?
Yeah, so you go for biologicals. Do you need feedstock for that?
Our inputs is off-gas from a point source, electricity and water. So for example, you have a biogas plant or a biomass combustion, so the off-gas that is vented today.
Okay.
Or steel off-gas, incineration of waste off-gas.
Interesting.
And you said that you differentiated by the highest degree of flexibility.
Yeah.
What does that mean?
It's 2 dimensions. It's the plant sizes, so we can build not just the large scale ones, but also the smaller scale to valorize the decentralized smaller scale. And with regard to the CO2 sources, and we also enable with our technology off-grid cases, which is not possible with state-of-the-art technology today, at least not economically viable.
And so, question: what is your business model?
A technology play like Topsoe, Johnson Matthey, where we kind of have a protected technology providing to our customers plant designs, so also a bit engineering work, which we then hand over to an EPC company which constructs the plants, and then also recurring revenue through maintenance and operation. For example, we also build digital twins for our customers, which then is kind of a software as a service.
What are the headwinds? I mean, what are the risks?
Risks. I think the main risk is suppliers, right? You work with multiple suppliers in those projects, a bit complex. And then also the decision-making process, more like a sales risk, I would say. A market, huge momentum, huge supply-demand gap. There's a lot of demand for the end product, so there's also a lot of interest for the producers to scale fast. So these 2 risks.
You aim to go to 55, which is the current state in the market probably, but I assume competition will come up and go also to 55 or lower. Can you go much lower than 55?
We do not know any company that can hit the 55 per megawatt hour price yet. We can also go lower, but that depends on the equipment that is needed for electricity production and hydrogen production.
Any short question? Last question?
How do you intend to grow the team?
Sorry, how to?
How do you want to grow the team?
I didn't really understand.
Grow the team.
The grow. We are in Mannheim with a huge ecosystem of process engineers. Ecosystem. There's the large-scale chemical players all around us, and we already have a great pool of the talents into our organization because it's climate tech. All people love this topic.
Good. Thank you.
Thank you
very much. Right. So let's take a 12-second break in which the people that sit on the stairs, if they want, they can come up. There's seats in the front. So I'm going to count to 12, and you can join the stairs if you want. 1, 2, 10, 11. You're very slow. Where's the energy? Come on. Okay, now we go all the way to the US with Mantle and Danielle Colson. She's COO and co-founder of a company that develops the first molten salt-based carbon capture technology. Danielle, you have the floor.
Mantle is the material solution to carbon capture. Heavy industry dominates global CO2 emissions, and carbon capture has a critical role to play into decarbonizing these sectors such as industrial heat, cement, steel. We also need to be removing CO2 from the atmosphere, and we can do this by pairing carbon capture with biogenic sources of carbon, such as pulp and paper or waste to energy. Now, all of this CO2 needs to be transported, either to be sequestered, essentially returned underground where it came from, or utilized, turned into useful product. But the key driver of cost is capture, and that is where Mantle is focused. Mantle's system captures carbon dioxide and recovers energy as steam or heat. We do this using our proprietary molten borate technology, a technology that was discovered by my co-founder during his PhD work at MIT. This material is the source of Mantle's technological and economic advantage. Our molten borates are the first and only high-temperature liquid phase material for capturing CO2. We capture CO2 by absorbing at 400 to 600 degrees Celsius. Here on the screen, you'll see a high-temperature camera that actually shows you this absorption process, our molten borates capturing that CO2. And the more exciting step, in my opinion, the desorption step, where we drive that CO2 off of the molten borates. Each one of those bubbles you see is a pure stream of CO2. Mantle captures CO2 using our Mantle boiler system. This off-the-shelf system with Mantle's technology integrated into it burns a fuel, produces pure CO2, 99.9% pure CO2, pipeline quality or food grade CO2, as well as steam or heat at any temperature or pressure that is needed. This system can be integrated at any existing heavy industrial site that is currently a user of steam or heat. All of this means that Mantle can drive the cost of carbon capture down to less than 50% when compared to other technologies. Technologies such as carbon capture with amines, electrification, or hydrogen, and well below the current incentive pricing set by both the EU's ETS system and the US's 45Q IRA. I'm Danielle Coulson, co-founder and chief operating officer at Mantle. I'm supported by my CEO, Cameron, who discovered the technology during his PhD work, as well as our CTO, Sean, who runs all the R&D. We've built an incredible team of academics as well as industry professionals with deep experience in carbon capture, molten salts, and boilers. The system you see in the back here is our pilot that currently captures 0.5 ton of CO2 per day, and we're building a demonstration right now that captures 5 tons of CO2 per day. Thank you.
See, that this is the energy I was talking about. See, the CO2 in the air. Let's go.
I hope not.
Well, there is a lot. Yeah. William?
Thank you for your pitch. Could you tell us a bit more about the molten borate? Like, how do you source it? Is it easy, economically easy as well? And how many times do you potentially need to replace it, maintain it within the installation?
Yeah, absolutely. So this is one of the nice advantages of our system compared to other systems. Molten borate is made up of commodity chemicals. It's primarily a mixture of borax and soda ash, which is sodium carbonate. These are commodity chemicals that are currently used for cleaning products, for fertilizers, and for glass manufacturing. These chemicals are shipped to site, and we actually do the synthesis right there on site in the furnace. The chemicals are in powder form. They're mixed together. They're heated up to synthesize. Really takes away a lot of the complicated supply chains that you often face in this industry. The materials will last upward of 20 years, depending on some of the impurities in the flue gas, especially SOx. We will capture SOx as a co-benefit of our system, but what that means is that some of the system will filter out, and we'll have to touch it back up with sodium calcinate. But other than that, it will last 20 years plus.
John?
What kind of customers will be your first focus?
Yeah, absolutely. So we're working really across industries with anyone who is a user of heat or steam on site. So Mantle's original system produces heat or steam as a byproduct of capture. And so really our key users are anyone who currently has a boiler on site. So this is petrochemicals, this is refineries, this is pulp and paper. Our demonstration project is being sited at a pulp and paper site in Quebec. It's essentially a standalone boiler that will decarbonize 5% of the site's emissions.
Okay. Hélène or Nicolas?
So what impact do you think you can have with that technology, I'd say, in the next 10 years?
Yeah, absolutely. Hoping to deploy many systems in the next 10 years. Globally, the market for carbon capture is $1 trillion market. When you take that down to where we're currently in the money, that's about a $200 billion industry. If we simplify that a little bit to Mantle's initial beachhead technology, which is this steam boiler, that's a $30 billion market. We're not going to reach all of that by 2030, unfortunately, but by 2030, we intend to have our or by 2020, what year are we in? 2024. By 2025, we intend to have our demonstration plant up and running. By 2026, our first commercial, and by 2030, hopefully a couple larger commercial plants as well.
A short question?
Yep, business model?
Sure. So long term, we're looking to be a technology provider, so looking to partner with EPCs, engineering, procurement, construction companies, to deploy and sell these technologies to our customers. In the short term, we recognize that there's risk and that people don't necessarily want to buy these large capital assets, and so also pursuing kind of a capture as a service model in which we will own and operate these systems, provide them to customers in a system where they pay per dollar of ton captured.
Good. Thank you very much.
Thank you.
I must admit, out of the 2 days, you are the most energetic group. You need to be with us today at 6 in the main hall as well, right? So we go to Switzerland now with Christina Sauter. She's CTO of 8things. scalable manufacturing platform to unlock mass production of breakthrough battery materials and designs. Christina?
Yes, thank you very much for this kind introduction. I'm Christina. I'm one of the co-founders of 8inks, and we are founded in December 2022 with a vision to contribute to a world with a fully circular battery economy on a scale large enough to store the world's renewable energy. And we want to get there by building a manufacturing platform to unlock the mass production of next generation battery designs. Because in our opinion, it takes 3 pillars to build the best batteries. It takes the right chemistry put into the right cell design, but all with the best production technology. And this is exactly where our patented technology comes into play. So battery manufacturing has not changed in the last 30 years, even though the demand is increasing tremendously and the e-mobility opportunity for batteries is estimated to be $1 trillion in the future. We are focusing on the core of this battery production steps, which is the coating, where you apply the electrodes on the metal foil. With our multi-layer curtain coating technology, you can optimize the battery for performance and for costs. Faster speeds and depositing multiple layers simultaneously will decrease costs tremendously, and simultaneously, because these multiple layers allow you a freedom of design, you can increase your battery performance, for example, higher energy densities and faster charging, all the while remaining compatible with existing infrastructure. We scale and tailor our production technology by starting with pilot projects, where we have just started our first customer project, and then becoming a contract manufacturer for niche market applications and licensing out our technology to the gigascale battery manufacturers. We are a diverse and tech-focused team with 4 co-founders, 3 of us, including myself, with a PhD from ETH Zurich, 1 Leon joining us for the business side with 5 years of experience at Google, 4 FTEs right now, and a great advisory board. And together we strive for a circular battery economy at scale, where we at 8inks provide the process freedom to implement sustainable designs. And we are always looking for partners along the entire value chain to help us doing that. Thank you very much for your attention.
Yeah, very interesting technology. Can you also recycle them afterwards? So can you get them out of each other again?
So this is part of our vision. So if you think of this layered design, and it's actually a little bit an Easter egg in our name, the 8 layers are the layers of a battery that if you coat them simultaneously, you can make it way easier to recycle them afterwards. And it's an approach that it's called direct recycling, so you can retract the particles directly without melting them down, without any black mass. So it's part of our vision. We're not completely there yet, but this is the idea.
Nicolas, yeah?
Yeah, maybe. Again, what is your business model and your market size, I mean?
Yes, so our technology is very, very versatile. So we start with demonstration of use cases, for example, next generation materials or solid state batteries, where we demonstrate our capabilities. And then we need to show that we can scale up. So we are focusing on niche market applications first, where we can focus on the performance aspect of our technology. And then when we have shown that, we will go to the large battery manufacturers to license.
The size of the market that you address, do you have a sense of it? I mean, in terms of dollars?
It depends very much on what technology. If we're talking about solid state batteries, then we're talking about 200 million sized markets roughly in 2030. If we're talking about the entire battery market, then it's in 2030, $1 trillion. Only for the e-mobility, only for EVs.
Could you tell us a little bit more about the technology, like what kind of challenges you overcame to get there and how replicable and protectable it would be actually?
Yeah, so I think the core of our technology is that a lot of next generation batteries are stuck in the prototyping phase. And we want to bridge this gap by focusing on the scalable production technology. And I think one of the challenges is definitely that our approach is this scaling up instead of focusing on only the performance. So we are focusing on both simultaneously, which is definitely one of the biggest challenges.
And do you have any patents, or how do you protect?
Yes, so the technology comes out of the PhD of one of my colleagues. We are currently in the process of an IP agreement with ETH Zurich, and the whole process is under this patent.
Good. Thank you very much. Right. Three more to go, and we go to the UK now with Equator and Stefan Georg, who's managing director. What they do is that they create clean fuels, and green chemicals from liquid waste.
Hello everyone, my name is Stefan Georg. I'm a co-founder and director at Aquature, and I would like to invite you to rethink wastewater as not only a topic in water, but also a topic for energy. Because what we do is we create green chemicals and green energy from wastewater. The way we do this is with a technology that's called microbial electrolysis, where we split the wastewater into three components. The organic fraction of the wastewater is converted by bacteria into energy that is then in a second part transformed into hydrogen, whereas the inorganic fraction is separated in the same step and we create green chemicals from that, such as caustics. And what's left over after that is the water. We do this in a modular system that is containerized and can be deployed at our customer sites, and we convert their wastewater on site there into green chemicals and reduce their virgin intakes of materials. This process is net energy positive. That means we invest less electrical energy than we get out in hydrogen. It's carbon negative, and the green hydrogen we produce is actually cost competitive with fossil energy at this stage already because of the multiple revenues that we make, for example, from the high value green chemicals we produce. Our core verticals cover a large section of the industrial wastewater treatment market that is growing at a large pace of 5%. Actually, only 20% of water is treated at the moment, so that there's still quite some room to go up. And we serve these markets with our business model that is a combination of a treatment as a service per cubic meter treated, and together with an offtake agreement for the green chemicals that we produce. At a later stage, we plan to sell our units for direct integration into our customer sites and retrofitting their existing operations. We have existing agreements with partners from several of our core verticals, and we're currently setting up a demonstration plan towards the end of this year with the Port of Antwerp-Bruges to validate our technology there. The impact that we have is quite strong. The conventional wastewater treatment currently emits 3% of global greenhouse gas emissions and consumes 3% of energy consumption, whereas what we do avoids 5 times as much of these greenhouse gas emissions. So if we were to install 70 plants, for example, in Belgium, we would offset the carbon emissions from all of the wastewater treatment in Belgium, and in addition to that, produce 500 swimming pools per year of treated water fit for reuse and 25,000 tons of green chemicals. Our team consists of 3 co-founders that are experts in each of the areas that are relevant to our technology, so water, biotechnology, and energy, and we're supported by a great engineering team and a great board of advisors. Thank you.
Very spot on. Thank you. John?
Yeah, I think your business model is interesting to sell it as a service, but it requires tons of money. Yeah? So how do you do that?
Yes, yes. So we indeed require quite some investment for the capex. That's why at an early stage we take the reason for this is because the water sector is very risk averse. So you need to move the risk to the company at first. At a later stage, when the technology is fully validated, customers are more than happy to buy the product. But for the beginning, you need to stick to a more risk-averse model, a business model in that case.
Investors lining up for that because they also are not per se risk-taking.
Apologies.
Investors, are they willing to chip in so much money that you can? do it?
Yes. There are several. So there are different kinds of investors. Some of them are actually specialized in water technology, and they know the challenges of water technology. And those are usually investors that understand these issues best and that are willing to invest as well.
Back on the technology, can you run this as a continuous process?
Yes.
Okay. That's a simple answer.
Any other questions?
Yes. You don't want to run it in batch. That's not beneficial for any part of the process.
Okay. What about the microorganisms that you use? Do they create any challenge in operating?
The microorganisms do have certain sensitivities to certain chemicals and these things, but part of our co-founding team is really strong expertise in biotechnology and water tech. So what we do is we control our process so well that the bacteria feel well at all times. In addition to that, you're talking about batch probably because of the microbiology, I imagine. The bacteria actually grow on the electrodes, which means that they are attached to it. And only the bacteria that you don't want actually are the ones that get flushed out. So it's it all works well the way that it does work.
Okay, thank you.
Oriane?
Given the fact that the bacteria create energy input for the electrolyzer, how much of outside energy do you need? And the underlying question behind it is, what's the target cost for hydrogen?
Yeah, okay. We are currently producing 20% additional energy compared to the electrical energy that we're investing. The theoretical maximum is at, I think, 700%. So there's quite some room to go. It's basically you convert the chemical energy in the wastewater into chemical energy in hydrogen. And we avoid the energy that you would, in a conventional electrolyzer, invest into making oxygen. So that's where we see ourselves there. In terms of costs, we are targeting a cost of below €1 per kilogram of hydrogen. That is an issue for us because we believe that we should be able to make hydrogen cost competitive with fossil fuels. And that is made possible through all of the products that we provide and the values that we provide in the services.
Good. Thank you very much. All the best. As Oriane wanted to ask another question, maybe you have questions for them. So don't forget, after the end of this session, you can find them on that door, and you can go to resources. And as I was telling you earlier, if you're an investor, some of them are really actively looking for investors. We go to Germany now with Sarah Fleischer. She's CEO of 2Zero, and what they do is to bring lithium-ion battery waste to zero. So let's go to zero.
Hi, I'm Sarah. I'm the co-founder and CEO of 2Zero, where we truly bring lithium-ion battery waste to zero. Everybody here should know we currently find ourselves in the hardest problem of humankind, which is to avoid climate crisis. This should not be a shock to anyone here, but we do have to bring 51 billion tons of CO2 to zero every single year. The good thing is we have a solution, which is batteries. We are in the area of electrification of everything. This also means here for Europe, we're going to produce so many batteries. And what a lot of people do not talk about, it's a great thing, it's a great solution. But what is happening with all this waste? So there's going to be a tsunami of battery waste coming upon us, and we have to fix this. Why is this? You might ask yourself, hold on a minute, if I buy an electrical car, the battery should hold 8 to 12 years, in best case. Why is this off? And the reason is 60% of our battery waste directly comes from gigafactories. So in the ramp-up phase, every single battery, more or less, has to be recycled, and this will continue in the next years. What's currently happening with these batteries? A very old technology, probably 3,000 years old. We throw the batteries into fire, very high temperatures, 1,400 degrees, and 50% of the valuable materials is lost, especially the white gold, the lithium that is in every single lithium-ion battery is lost in this process. Also, graphite burns into CO2. This is removal. This is not recycling. And this is exactly where we come in as 2Zero, where we truly close the loop for batteries and extract all these critical raw materials, bring it back into the circle to produce new batteries. How do we do this? We have a breakthrough. With our novel hydrometallurgical process, for the non-chemist, this is a chemical process, and where we can target specifically this lithium and this graphite without using chemicals. We are agnostic. We do not care if it's an NMC battery, LFP, LCO. So basically, in other terms, is it a car battery, an iPhone battery? We do not care. We are 7 times cheaper than our competitors in China with German wages. And number 3, we do not produce any waste streams. So we are based in Munich with our initial funding with 3.5 million euros. We scaled up from lab scale to industrial scale, and we currently basically serve 9 different countries here in Europe and offer our service. If we do this right, by 2040, we can cover 72% of Europe's demand of this white gold, the lithium, which I have here in my hands. So we have proven our technology with our partners, with customers. They love it, and this is the awesome team that is behind it, and we're super excited to move this forward. Thank you. He wants to steal my white gold.
Yeah, let's see what this is about. It's not empty. So who wants to start? John?
Carefully open it.
Okay. Maybe you can tell us about the technology behind that, because it sounds like it's magic.
It is magic, no. For those who understand chemistry, it is quite simple. It's a hydrometallurgical process. We have figured out the organic additives that can specifically target the lithium and graphite and allows us to extract them separately in one single process step. And that is something that has never been done before. As a good comparison, the Chinese, who have matured this process for the last 10 years in China, using with a lot of aggressive chemicals, they have roughly 20 steps. We have 1 step. That makes us difference.
And you have strong protection against your technology?
Strong
you have strong protection for your technology? I mean,
yeah, we have submitted a patent, but we also go for a clear IP strategy with trade secret. See it as the Coca-Cola recipe. We do not tell anyone what organic additives we use. We do not show anyone what variables we use from our processes and what equipment we use. And all that together, that allows us to do our technology.
Could you tell us a bit more about how do you get the black mass today and what's your traction so far?
Ooh, an expert here. Yes, for those who don't know, the first step, you take a battery, you dismantle it, you shred it. It's probably a 100-year-old technology out there. In every single country in whole Europe, you have shredding partners, like here in France, Veolia and Snam are good examples. We extract and receive as a normal commodity from every single country. So those are the 9 countries that I was referring to. So we have shredding partners across whole Europe.
And can you tell us about the quality of the compounds that you're getting?
The lithium?
Yes.
Oh, yes. The white powder. Maybe one step back. If you do mining, very traditional as well, when you extract it from Latin America or from the ores from Australia, you have a purity rate of 20%, maybe maximum 40%. You ship it all the way across to China that purify it, because they're the ones who have the capabilities in this world. And they bring it to over 80%, over 90%, depending on which industry requires it. Our process, we're almost hitting 90% today on industrial scale.
And cost-wise, so is it cheaper still to burn it or to get it from you?
Oh. With burning, you don't receive this at all, so this is completely lost. You cannot compare that. We can compare ourselves with the mining industry. So we're at the same price point as lithium from Chile, but with a different purity rate. So that makes a big difference.
So it sounds like everybody should do this. We should just make it happen, or not?
So what's wrong with it?
Why are they not big in the market yet?
Well, we are one of the first. I mean, there are other great startups out there that are also pushing forward this. We are in this new era. Again, we are all here to disrupt the old technology, which is pyrometallurgy, where you cannot extract this lithium. And I think the difficult part is scaling. You need a lot of money to scale this up. So we need everybody's support here.
Thank you.
Don't forget your gold, white gold. Now, if you have money to invest, magic, right? Now, the last but not least, HSL Technologies from France, with Belén Moreno Fresneda, account executive, innovative hydrogen carrier that transports and stores hydrogen safely like any other conventional liquid.
Thank you very much. Hello tomorrow for this opportunity. Members of the jury, happy to meet you here. I'm Belén Moreno, and I'm very happy to introduce to you the technology that we have developed. We have developed a way to transport and store hydrogen, because in a world where hydrogen can help us reduce the usage of fossil fuels and also our carbon footprint, we have a small problem with it, is that its logistics still remain complex and expensive, because either we need a very high pressure or a low temperature to transport it. But what if we could do this, not only at the ambient temperature, at ambient pressure, but also reusing the infrastructure that exists already for hydrocarbons? Very easy, HSL Technologies. Our technology actually consists on two processes. The first one consists on charging hydrogen into silica, common silica that you all know, like sand. I think there's sand later, so maybe I will take some to charge hydrogen in it. Once we have done this near hydrogen production facilities, we will have a molecule which is completely stable at ambient temperature and pressure. This has a main advantage, which is the fact that it's going to behave very similarly to hydrocarbons, and also is going to reduce drastically the volume that we are going to need for this transportation. We are actually going to reduce by 7 the volume of the hydrogen transportation that we know today. And last, what we are going to do is that we are just going to combine water with the molecule to get the hydrogen out of it. This is interesting for two things. The first one, we have hydrogen with no energy input. We are the first and only liquid carrier to do this. And the second one, this is going to be done at places where energy is not available. This molecule is also going to allow us to connect hydrogen producers and consumers without any regard on distance, quantity, safety, or price, because we are actually going to reduce drastically prices as well, as we are just going to use the same infrastructure. This, of course, by partnering with logistics and producers, so upstream value chain players, and we are going to sell this to hydrogen players here to transport overseas, develop mobility, and store hydrogen long-term. All this by using our hydrogen stored as liquid technologies, patented solutions that have more than 70 patents worldwide. And all this, of course, is thanks to partnerships, co-developments, and investments, because today we count key players of the value chain as investors, but also experienced members of business and technical background that are on our core team, all this with 20 Italians that support the technology. So if you want to join our revolution, if you want to join the energy transition together with social transition, that's definitely us, HSL Technologies. Thank you very much.
Anyone? John?
Yeah, just looking at your technology, so you're going to put it in silica, which can then be transported. Is it just one kind of application you're going to do in silica, or are there multiple different?
So actually what we do is that we just take silica and we combine it with hydrogen, so we do a liquid. This liquid actually remains stable, and we can transport it. And once we have done the release of hydrogen out of the molecule, as silica is non-organic, we can just bring it to the place of departure and reuse it as many times as we want. This is actually a circular process.
And now, how is this better than ammoniac or ethanol, which are also being used as LOHCs?
So ammonia first is toxic, so this is actually going to be a little difficult to bring it to for example, port hubs. Today, not all the port hubs accept ammonia. Let's not even talk about the middle of a city. Our solution is non-toxic. It's compatible with infrastructure that is there already, for example, in a refueling station. That's for ammonia, and for LOHC, well, we don't need energy at the point of release. This is the main advantage we have, because we need energy where it is available.
Ellen?
And what about your business model?
So the business model is actually thought to get the most impact of the solution. And for this, what we are doing is that we are going to deliver the molecule to final clients, final end users of hydrogen, by furnishing the release reactor so they can use the hydrogen into the carrier. The business model would actually valorize not only our patent portfolio, but also all the innovativeness behind the more than 8 years of R&D that we have.
Could you tell us a bit more about the overall storage efficiency within the liquid silicon?
Sure. So the efficiency, it's not the best, to be honest. At the charging part, we are going to have some hydrogen consumption. That's something we cannot avoid, because there's a need of energy at any point. That happens with all carriers. But the main advantage we have is that the energy is going to be needed at the charging point. If we are going to charge hydrogen from produced from green sources, that's actually where energy is available. But for the release, and that's where it comes interesting, we have an exothermal process. There's some extra heat we can actually revalorize. For example, mobility, one of the applications we have. We could actually reuse this heat to, for example, put the heat on a vessel. So basically, there is a 40 kilowatt hour need, and then a 26 kilowatt hour recovery. That's not perfect, but it's the best we could do, and we are trying to get better every day.
Short question.
Yeah. What about the price that it adds for the transportation?
Same price as hydrocarbons for storage. We just need to take care of having a slow hydrogen.
Thank you very much.